Hello, my name is Bijidir. Today my topic is complex SQL predicates as quantifiers from database management system. Uh, we propose a logical framework to analyze complex predicates, those involving in subquery in SQL. We propose a new operator in the relational algebra for handling such predicates and study its properties and how it combines with traditional relation operator. We focus on predicates of the form at theta mod is where ATT is an attribute, theta is a comparison operator, mod is one of some or all, and this is a correlated or non-correlated subquery. We provide a characterization of the predicate as well as implementation and operation optimization strategies for it. We show that our approach is extendable, so we can support the expression and optimization of other similar predicates. Finally, we describe experimental evidence that our proposed approach is more efficient than the traditional approach across a variety of conditions. One of the main issues is relational query processing and optimization is the processing of subqueries. Nowadays, most query processors use nesting to support this feature. However, this approach introduces difficulties of its own, which has been the subject of much research. One of the issues that has been created some challenges is the handling of universal quantification. Although this is a logical feature, relational algebra does not have a direct counterpart for it. Relying on rewriting with the extensional quantifier and negation. However, such translation is not always possible, and even when it is, it may lead to non-efficient implementations. In this paper, we focus on complex SQL predicates that use subquery and quantification. There are the comparisons between an attribute and a subquery using the modifiers sum and all. There are three basic reasons for our choice. First, as we argue next, comparisons with all are badly supported in current approaches. This motivates our search for optimization methods. Second, many other types of subquery can be reduced to this particular type, so approaches to the optimization of this case can actually be applied in a wide variety of cases. Third, the basic ideas behind this type of condition can be easily generalized in our framework, making some SQL queries easier to write and support. SQL join operators. In a join, the relational join operation merges rows from two tables and returns the rows with one of the following conditions have the common values for common attributes. This is called natural join and usually refers to attributes linked by a foreign key constant. Meet a given join condition, have a small values in common attributes or have no matching values. This is called an outer join. Example: select P number from P as project, D as department, E as employee, where P dnum is equals to D dot D number and E dot SSN is equals to 1 2 3 4 5. The from clause indicates which tables are to be joined. If three or more tables are included, the join operation takes place two tables at a time from left to right. If R joining table T1, T2, T3, the first join is T1 and T2 with T2. The results of the join are then joined with T3. The join conditions in the wait clause tells the select statement which rows will be returned, that is, those tuples that satisfy the condition. The number of joined conditions is always equal to the number of tables being joined minus 1. For example, if we are joining T1, T2 and T3, we need to have two join conditions J1 and J2. All join conditions are connected with an AND logical operator. Generally, the join condition will be equality comparison of the primary key in one table and related foreign key in the second, or any additional tables, or an inequality condition. Cross join. A cross join performs a Cartesian product of two tables. Syntax: select common list from table 1, cross join table 2, select from P cross join B. Natural join. Uh, Natural join returns all rows with matching values in the matching columns and eliminates duplicates. Syntax: select column list from table 1, natural join table 2. The natural join will perform the following task: determine the common attributes by looking for attributes with identical names and compatible data types. Select only the rows with common values in the common attribute. If there are no common attributes, return the relational product of the two tables. Outer join. An outer join returns not only the rows matching the join condition, it returns the rows with unmatched values as well. There are three types of outer joins: left, right, and full. The left and right designations reflect the order in which the tables are processed by the dbms. The first table named in the from clause is to be the left side, and the second table named with the right side, and so on. The left outer join returns not only the rows matching the join condition, it returns the rows in the left table with unmatched values in the right table. Syntax: select column list from table 1, left outer join table 2 on join condition. Example: this following query lists the product code, vendor code, and vendor name of all products, and includes those vendors with no matching products. Select P code, V code, V name from vendor left join product on V code. The exists and unique functions in SQL. Exists function: check whether the result of the correlated nested query is empty or not. Exists and non-exist, typically used in conjunction with a correlated nested query. SQL function unique returns true if there are no duplicate tables in the result of query. Uh, SQL mean. Complex SQL is the use of SQL queries which go beyond the standard SQL of use select and where commands. Complex SQL often involves using complex joins and subqueries, where queries are nested in where. Complex queries frequently involve heavy use of and or clause. Complex SQL queries go beyond the standard uh, commands such as select. These queries can use many command embedded clause to weed out irrelevant information and join different tables. One frequent used SQL technique is the use of subqueries embedded in a query with parentheses. Another technique is a self join, which treats one table as two different tables, allowing it to match multiple values in a row. While these queries allow for very specific and flexible searches, the disadvantage is that they can be hard to understand.